Good afternoon, Pankhurst. This is your Thursday maths lesson. Thank you so much to everyone who joined in today's live session this morning. It was really fantastic to see so many of you on there. I know that some of you have really found the part-whole model tricky last week. So what we're going to do is I'm going to start off going through a couple of examples with you on my whiteboard, and then if you're still unsure of it, if you just let me know via email or on Tapestry, then I'll make sure that I'll go through it again tomorrow, or Mrs. Mercer will go through it with you next week. So I'm going to go through some examples. So all I need you to get from me now is your part-whole model that we put in your emergency pack. If you haven't got that, just a scrap piece of paper, and if you could draw your part-whole model on there, then that'd be brilliant. I'm going to share my screen, and hopefully you'll be able to see a camera for my screen today. Have a look. Okay, so hopefully you'll be able to see this. I've got a whiteboard here. So my first question is going to be 63 divided by 3. So can you write that for me? That would be fantastic. If you could write that on your whiteboard or your scrap piece of paper or your part-whole model, and then we're going to draw our part-whole model. So top of my part-whole model is going to be 63 divided by 3, and we're going to be splitting it, we're partitioning our 63. So I'm going to draw my part-whole model there. And in here, I had 63, so I'm going to split it into 60 and 3. And the reason I'm splitting it is because it's easier to split, to divide the 10s and then the 1s. But also I know that 3 goes into 60 and 3 goes into 3. I know that because I know my 3 times tables. So I'm going to write here 60 divided by 3. And I'm dividing by 3 because that's what my question is. And on this side, I'm going to write 3, because that's what I've got left, divided by 3. So they're my 2 questions. So that's what your part-whole model should look like right now. Now I'm going to draw my table to help me with my understanding. So I'm going to just move my mouse a little bit so it doesn't get in the way. I'm going to draw a table. So under here, and because it's on my whiteboard, and if you're doing on your part-whole model, that's fine as well, I'm just going to draw it nice and quickly. I'm going to draw, got my 10s, and my 1s at the top, and I need to have 3 rows. I need to have 3 rows because I'm dividing by 3. That's what my question is asking me to do. That means I'm sharing it into 3 groups. So I'm going to do 3 rows. 1, 2, 3. Now, if we were doing it in our book, we would use a ruler. Because it's a whiteboard, it's fine for now. Then I need to share my 60. So I've got 6 10s. That goes in my 10s column. I'm going to share it into my 3 rows. 1, 2, 3, 4, 5, 6. And then here I've got 3 1s to share. 1, 2, 3. Now when I did this last week, do you remember I named my rows? So I might have said that Ritesh is getting this row, or Wes is getting this row, and Shrivir is getting this row. So you can do the same thing. So this person is getting this many of whatever you're sharing. So my answer is 2 10s and 1 1. So my answer to my question is 21. Okay. So hopefully you've done that on there. Now I'm going to do another one now, and I'm going to ask you to do this one on your own. I'm just going to wipe my board. Okay, let's try another one. This time I'm going to try 39 divided by 3. So I'd like you to start in your part-whole model at the top. I'd like you to do 39 divided by 3. And now I'm going to ask you to do this. So in your part-whole model underneath that, I'd like you to write down what it's going to be if we're going to be partitioning this number. Remember, both are going to be divided by 3 because that's what our question is. But we're going to be splitting it. So I'd like you to pause the video now and write down what you think goes in those circles, please. Okay. If you have said 30 divided by 3, that's fantastic, because that's how many tens we've got. We've got 3 tens, which is 30. Then we've got 9 ones. So I should have 9 divided by 3 over there. So well done if you got that as your answer for your part whole model. Now we're going to draw our table. So I'm going to draw mine, and then I'm going to ask you to pause the video so you've got a chance to draw yours. So again, I'm going to have my tens and my ones. And again, if you were doing this in your book, would you be using a ruler? And I need 3 rows again because it's divided by 3. If it was divided by 5, I would need 5 rows. So I'm going to have 3 rows, 2, 3. And I'd like you to pause the video here. I'd like you to show me how you would do your 30 into 3 rows and your 9 into 3 rows. So pause the video now. Okay, hopefully you have shared your 30 into the 3 rows. So you'll hopefully have 1, 2, 3, because it's 3 tens, and 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you now write down your answer for the question? So this is how many are in one of those rows. Can you work that out for me and pause the video now? Okay, I've got 1 10 and I've got 3 ones. So the answer to my question, if I write it back up here, is 13. So if you got that, that's fantastic. Well done. That's really, really good. Okay, we're going to go on a slightly trickier one now. And I'm going to only do one example of the trickier one. And if you still need some help, that's absolutely fine. Just let me know in the live tomorrow. I'm happy to go over it again. So the example I'm going to give you now is slightly trickier. It's going to be 87 divided by 3. Now, the reason this is trickier is because 3 doesn't go into 80. And 3 doesn't go into 7. So it's a little bit trickier. Because if I counted in my 3s, 3, 6, 9, it doesn't go into 7 very easily. So I need to partition it differently. So I'm going to draw my part whole model, which is 87 divided by 3. I'm going to split it again, like the one you've got. And again, they're both divided by 3, because that's my question. However, 87 can't be divided by 3 easily. So I need to split it up into things that I know 3 goes into. Now I know 3 goes into 60. And I know that because I know 3 goes into 30. And if I double 30, it's 60. So I know it does. And I also know that 3 goes into 6. So it works. If you're not sure what it goes into, you can just write down the side your 3 times table, and that will help you. So I know that it goes into 60. So that's going to work fine. There's my 60. But it's not 60 I've got to divide it by. It's 87 that I'm dividing. So I've already got 60. What have I got left? So I've taken, I need to do 87, take away 60 and see what I've got left. And that's going to go in this circle. So I'm going to do that over here. 87, take away 60. 7 take away 0 is 7. 8 take away 6 is 2. So I've got 27 left. Now I know my 3 times tables, and knowing your times table really helps here. I know that 3 goes into 27, so I know that this one is going to work. Okay, let's have a go and try it. I'm going to draw my table. Again, I need my 10s and my 1s at the top. And again, I need 3 rows because I'm dividing by 3. I've got 6 10s, and here I've got 27. I'd like you to pause the video now and see if you can work out how you're going to split it up. Off you go. Okay, let's have a look. So I'm going to split up my 6 10s first. 1, 2, 3, 4, 5, 6. Then I've got 27 ones. Let's have a go. 1, 2. Let's do it in circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good thing about a whiteboard is I can make my box a little bit bigger. And I was up to 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I've got my 27 and I've shared my 10s over here. So now I need to see how many I've got in each row. Now I know that 60 and 27 have worked here because it's all equal. There's 2 there, 2 there, and 2 there. So 60 works. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 there, 9 there, and 9 there. If these weren't even, these weren't equal, so if there was 9 here but 8 here, then this number here wouldn't have worked. That's how you can check. If it's equal, then you know it's worked. So I'm going to look at how many's in one row. So I've got 2 10s, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer will be 29. Now I can check that now. Some of you will know that I could do the inverse. The inverse of divide is multiplication. So if I did 29 multiplied by 3, 9 times 3 is 27. 3 times 2 is 6. Add the 2 is 8. I get 87. So that's how I can check my answer. Some of you can do that as well. Now I know that can be a little bit complicated. I'm just going to stop sharing my screen with you. I know that can be a little bit tricky. So if that's still not making full sense, just let me know tomorrow in the live or on Tapestry or in an email, and then I'm happy to explain it again or make sure we have an extra lesson on it as soon as we can. Okay, let's have a look at today's lesson. So yesterday you were having a look at some sequencing. You looked at some t-shirts and jeans and some different desserts and how you could sequence it so they go together. We're going to be doing that again today. We're going to try and look at it using different combinations and how we can use multiplication to help us. So the learning objectives today is, can I calculate the possible combinations resulting from 2 groups of objects without listing them? So here we have got the Masternodes picks 1 red card and 1 black card. So we've got 4 different red cards and 3 black cards. And it says, how many different possibilities are there? How many combinations contain the black 8 card? Yesterday we looked at working systematically to work out how many combinations there are. Let's move the cards to do this. Now, what I said in the live this morning, systematically means when you're working something out using a pattern. So you can use it a systematic way, so you're using it through a system to where it's come from to help us work it out. So we need to see how many different possibilities there are. And there's some grids down here to help me. Now to do it systematically, if I did it randomly, I might go, just one of those, one of those, one of those, one of those. And it's quite difficult to remember which ones you've done. Because when it gets to the end, you won't remember if, oh, have I done the red 5 and the black 7? It'll be tricky to remember. So we're going to do it systematically to help us work it out. I'm going to show you how I'm going to do it. I'm going to do red 4, black 6. Then I'm going to do the red 4 again. Red 4, the black 7. I'm going to do the red 4 again, and the black 8. They're all the red 4 combinations you can have that have 1 black and 1 red card. Then I'm going to do the same with number 5. I'm going to move these, so I think it'll be easier to see them if they're going down. Let's put them down here instead. Okay. Let's try with the 5. 5, red, black, 6, red, 5, black, 7, red, 5, black, 8. Again, it's systematic, so I remembered which ones I've done. I'm going to try with the 6. Red, 6, black, 6, red, 6, black, 7, red, 6, black, 8. And then my last one is a red 7, black 6, red 7, black 7, and a red 7, black 8. So I've done that systematically. There's all my red 7s and the options, there's all my red 6s and the options, my red 5s and the options, and my red 4s and the options. Then the question says, how many different possibilities are there? Now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possibilities. How many combinations contain the black 8 card? Well, let's have a look. None of these contain the black 8 cards because I put the black 8 at the bottom. So 1, 2, 3, 4 contain the black 8 card. So that's how we've done it systematically to help us remember where they go and which ones we've done already. Okay, let's carry on. So the Masternodes picks 1 red card and 1 black card. Is there a quicker way of doing it other than the way we just did it? So I just laid them out like this for us. Now it's asking us here, is there a quicker way of doing this rather than placing the cards next to each other? Can we find the total number of combinations without having to write them all out? Now, I discussed this with some of you this morning on the live session. We can use multiplication to help us. All you have to do is we need to see how many of these cards do we have, which is 4. And how many of these cards do we have, which is 3. And it's a multiplication because we're grouping them like we just did there. We grouped them together. So I'm going to need to find out my answer. 4 times 3. I'm going to count in my 4s, or you can count in your 3s. 3, 6, 9, 12. If you know your 4 times tables, you could have done 4, 8, 12. So my answer is 12, which is exactly the same answer that we had here. I just didn't need to group them. I just did my multiplication. So let's use that to help us with the next one. Eva chooses a snack and a drink. So she's got a pear, an apple, a donut, a banana, and some sweets. And her drink option is water, cola, and I think it's orange juice. What could she have chosen? How many different possibilities are there? Now, what you can do, you can draw this to help you if you want to, you could group them. So you could write pear and water. So if I was to write down my list of things, I might say she could choose a pear and water. I'm going to do it systematically. So she could choose a pear and cola. And the last pear option is pear and juice. Then you might do the same with apple. So you would do apple and water, apple and cola, apple and juice. Then donut and water, donut and cola, donut and juice. You can't do apple and donut because she's chosen a snack and a drink. So you can write them all out. And that's absolutely fine if you need to do that to work it out. That's not a problem. But a quicker way of doing it, like I just showed you, is to do multiplication. How many of her options does she have here? Multiplied by how many does she have here? I'd like you to pause the video and write down what my multiplication question is going to be to work out my answer. Okay, so my first one is how many of the snacks has she got? She's got 5 snacks. So my question is going to be 5. And then how many drinks has she got? She's got 3 different drinks. So to work out how many possibilities there are, it's going to be 5 times 3. Now you know your 5 times table, so we can count in our 5s, 5, 10, 15, so my answer would be 15, or you can count in your 3s, 3, 6, 9, 12, 15. So the number of possibilities there are is 15. So like I said, you can write them out to help you, but there is a quicker way of doing it. You just multiply how many there are each. Okay, let's have a look at this one. Slightly trickier now. The Masternaut has some different spacesuits and some different helmets. He can make 18 different outfits. How many of each item might he have? You could either try to use your knowledge of the times table or write out the combinations. So if you know your times tables, you can work this out by knowing something times something is 18, because there's different options for this. Or you can draw out your combinations. It's whatever you find easier. So I might do my combinations to show you as an example. So I might choose to have, if I share my screen, I'm going to rub up my whiteboard again. I'm going to share my camera again to show you how you could do it. Let's see if this works. So I stop sharing on here and I share my screen on my camera again. Okay, so we've got to have 18 combinations. I'm going to write the number 18 just so I remember. Okay, and he's got to have, I'm just going to have a quick recap of the question to make sure I get it right. So it says he has different spacesuits and different helmets. So I'm going to say he's going to have a red space suit and a green helmet. That's one option. So I'm going to choose my options up here. I'm going to choose to do a green helmet, a blue helmet, and a yellow helmet. And then the number of spacesuits I'm going to choose to do a red spacesuit, a blue spacesuit, and let's have a look, an orange spacesuit, a pink spacesuit, a green spacesuit, and a black spacesuit. Okay, so let's do our options. I've got a red spacesuit with a green helmet, a red spacesuit, and a blue helmet, a red spacesuit, and a yellow helmet. You could then do that. So that's my red one's done. I can move on to my blue one. Blue spacesuit and green helmet, blue spacesuit and blue helmet, blue spacesuit and yellow helmet. Sorry, I hadn't moved the whiteboard up. And you can carry on doing that all the way down. But you have to get 18. You have to have 18 options. Now, if you only choose to have 2 different spacesuits and 2 different helmets, you're not going to get 18. You're only going to get 4 options. So this might take you a while because you might have to keep adding some spacesuits or adding some helmets to work it out until you end up with 18 different options. However, a quicker way of doing it is if you know your times tables, you can work out what times what is 18. Now on my smartboard that I just showed you, if I can find it, here we go, that gives you an example. 1 times 18 is 18. That means you could have 1 spacesuit option and 18 helmet options, and that would still give you 18 combinations. Or you could have 18 spacesuit options and 1 helmet option, and that would also give you 18. I'd like you to pause the video and I'd like you to try and work out some other options. Now, you can see that they've turned it around. We've done this before, whether you can have the numbers either way around, that's fine. I'd like you to pause the video and I'd like you to find 4 multiplication questions that make 18. Now I want you to have a think about it. I want you to count in your 2s, you could count in your 3s, see if you can work it out what it could be. Or if you need to draw your options of spacesuits and helmets, that's absolutely fine. You can draw your pictures, or you can just do it like I did and just draw your letters. See if you can make 18. I want you to work through it really carefully, because it might be a bit of a trial and error and you might have to add a few more if you're finding it too tricky. Let's have a look if you can try that. So pause the video now and give that a go. Okay, if you know your times tables, then hopefully you've been able to work out some different examples. So I'm going to show you some answers on here. So he could have 1 spacesuit and 18 helmets, 18 spacesuits and 1 helmet, 3 spacesuits and 6 helmets, or 6 spacesuits and 3 helmets. So if you've got any of those, you can give yourself a tick. You could have 2 spacesuits and 9 helmets, or 9 spacesuits and 2 helmets. So well done if you've got any of those. If you drew your pictures or wrote your letters to help you, well done for getting that. If you know your times tables, you would have found that simpler. Sometimes it's a bit tricky to know our times tables. If you know your 1s and your 2 times tables, you would have hopefully got those ones at least. So well done. Okay, let's have a look at the activities you're going to do by yourself today. Remember, you can always draw things or write things out to help you if you're unsure of your times tables, or you could check your answers using your times tables or drawing your pictures. So activity 1, Avani, you're in this one. Avani chooses a colouring pencil from the following colours: red, blue, pink, yellow and green. She then chooses a piece of paper from the following colours: white, purple and brown. How many different combinations could she make? So Avani has got 5 colouring pencils, colours, and she's got 3 coloured paper. She needs to multiply the number of colouring pencils she's got by the number of pieces of paper. Again, if you need to draw or write anything out, that's absolutely fine. The next question, it says Tiffany can choose between these meals at school: beef lasagna, veggie lasagna, pasta veg, or jacket potato. She can then choose one of these desserts: yogurt, cake, or fruit. How many different combinations could she have? See if you can work that one out. Then activity 2, which I think the majority of you can definitely try, because like you said today in the live, a lot of you found yesterday's lesson okay and you understood it. The cafe sells some different sandwiches and some different drinks. It advertises that altogether there are 24 possible combinations to be made. How many different sandwiches might it sell and how many different drinks? So again, using your times tables, you can work out as long as your answer is 24. Think about what numbers go into 24. You could try your 1 times table, your 2 times table, your 3 times table, your 4 times table, your 6 times table. Use any of these to try and work them out. And the next one says the clothes shop sells some different coloured hats and some different coloured scarves. Altogether, there are 20 possible combinations. How many different colour hats might there be and how many different coloured scarves? Again, have a think about what numbers go into 20. I know that the part whole model work was quite tricky at the beginning of this session, so if you need some help on that, just let me know. Good luck. I'm hoping you'll find today's session a little bit simpler than the part whole ones that we did last week. And I will see you tomorrow morning on the live at 9 o'clock. Bye, Year 3.